Okay, here's one more video of practicing a bunch of these factoring problems. I realized in my previous videos I did a lot of the more challenging problems, but just the sort of everyday regular trinomial, let's see how this can be done quickly in practice here. Right? So we've got 3x squared minus 8x minus 3. I notice 3 is a prime number, so the only way to get 3x squared is 3x and x. Great. Here, 3, another prime number. The same prime number. The only way to get 3 is 3 times 1. I know this can't possibly be correct because 3 is a common factor here. If this were the case, I'd be able to factor out a 3 from this expression. But 3 isn't a common factor all the way along. So, and I know I'm messing up the pluses and minuses, but you get the idea, right? Whether this is plus or minus. If 3 is a common factor here, it would also have been a common factor here. So I know right away that my my constant term here has to be 1 and 3. If it's going to work at all. Maybe it doesn't factor, maybe it's prime. Right? To get negative 3, it's got to be 1 positive, 1 negative. So 3x squared, negative 3, good. Check the outer inner. 3x times 3, 9x, negative 1 times x, 9 minus 1, 8x. No, I want negative 8x, so everything's got to flip signs. So 3x plus 1, x minus 3. 3x plus 1, x minus 3. Next, 2x squared minus x minus 15. Okay, another prime number here. Those are the best because there's only one choice. 15 not prime. All right, it's either going to be 5 and 3 or 3 and 5, 15 and 1, 1 or 15. Now this is negative, so I know the signs are opposite. And I know their difference is negative 1. So I need the negative product to be 1 higher than the positive product. If I do 5 and 3, that's giving me 10 and 3. That difference is not 1, so that's wrong. 3 and 5, that's giving me 6 and 5. That difference is 1. I want it to be negative 1, so I want negative 6 plus 5. Right? Negative 6x plus 5x is negative 1x. Good. 5 times negative 3, negative 15. So 2x plus 5, x minus 3. All right, 15x squared. Now I don't have a prime number in my leading coefficient, but I do have a prime number in my constant term. So I know 7's got to be 7 and 1. It's positive 7, I was a little sloppy there, and a positive 26. So to get positive, they have to be both the same sign, and if they're adding up to a positive, it's got to be plus there. So how do I add up to 26? Well, 7 times 5 is 35. That's higher than 26. 7 times 15, that's even bigger. I could do 7 times 1. Let's see, right? 1x times 15x is 15x squared. So 7 plus 15, 7, 8, 9, 10, 11, 12. That's close, but still not good enough. So that doesn't work. So let's just start again, 7 and 1. Instead of 1 times 7, I need that to be a little higher. Maybe it's 3 times 7, which means this has to be 5. 3 times 7 is 21x. 1 times 5 is 5x. 21 plus 5 is 26. And just double check, 3 times 5 is 15. 1 times 7 is 7. There we go. So here's 3x plus 1, 5x plus 7. Right. Just guess and check. Don't be afraid to get it wrong. But if you're wrong, right, my first guess here was wrong, use that to guide, okay, I need this outer inner to add up to something a little higher. So I need to boost that 7. That's why I need that to be 3. Right? We need to be able to factor these quickly. We need to be able to multiply, do that FOIL process quickly so that this guess and check doesn't take us all day and all night. Okay, 12b squared. I hate 12 because it's got so many factors. But let's see if we can do this. 12b squared plus 13b minus 35. Okay, minus here. That means one of them is going to be plus, the other is going to be minus, right, to multiply to a negative. And that means their difference is going to be a positive 13. So let me just pick 4 and 3. I usually start with the closest together. 35 is 5 and 7. Let's check that out. 4 times 7 is 28. 5 times 3 is 15. Negative 28 plus 15, it's bigger, 28, 15, 8 minus 5 is 3. I've got it, except it's negative. All right, I got negative 13b, I want positive 13b. Right? Don't be afraid to guess. Often your first guess will be almost correct or close enough that you can then figure out what it has to be. Right? I could have done 6 and 2. I could have done 2 and 6, 3 and 4. I could have done 7 and 5. There are lots of different ways you could sort this out. I tend to find that the closer together numbers are more frequently used. I'm at 55. And 3b plus 7. Okay. Next, 3a squared, oh, back to a prime number, great. 3a squared minus 2a minus 8. Again, a minus, so one's got to be plus, the other's got to be minus. Could be 1 and 8, I'm going to guess 2 and 4. Okay, 4 times 3 is 12. And 2, no, that difference is not 2. So let me switch around. Oh, what just happened? Let me switch around those 2 and 4. 6 and 4. Yes, that difference is 2. So let me double check the signs here. So 3a times a, 3a squared. 3a times negative 2, negative 6a. 4 times a, positive. Negative 6 plus 4, negative 2a. Good. And 4 times negative 2, negative 8. All right. So 3a plus 4. I guess that was my second guess this time. A minus 2. All right, 28x squared. 28 is not prime, but it doesn't have the most choice in the world. All right, 20 also not prime. Now, I kind of have been skipping this just because it's so quick. I do it in my head. Common factors here? No. 51 is an odd number. The only factors of 20 are 2 times 10, 2 times 2 times 5. 2 and 5 both don't go into 51. No GCF. No GCF means I'm not going to have 4x and 7x linked with 4 and 5, right? Just like the previous example, I know that can't possibly be it. It might be 4x and 7x. We don't know yet. It's positive and positive, so that's all going to be positive. So 20 might be 5 and 4. That doesn't have a common factor here. So let's check that. 4x times 4, that's 16x. 5 times 7, that's 35x. 30, 46, 47, 59, 50, 51. There we go. Right? If that didn't work, 2's not going to go here, 10's not going to go here. The only way for this not to have a common factor is if this is either 1 and 20, or if this is 5 and 4. And if none of those work, then I would try 28 as being 2 and 14 or something else, right? But we got it. 4x plus 5. A lot of these guesses are just kind of instinctual from decades of practice. Now, I think back to when I was learning this stuff, when I didn't have decades of practice, even just a few weeks of practice, I developed a bit of an instinct. And I've seen that in other students, that you get a hang of it as to what seems to work well. So you're not having to go through 20 guesses each time. All right, here, this one's a little bit different. My c is at the end. We can still do it as written. 20 plus 6c minus 2c squared. Where I'm putting the c at the end, right? So 2 is a prime number here. So I've got 2c and c. It's negative, so one of them's minus, the other's plus. All right, 20, I can't put an even number here, so let me do 5 and 4 and see if that works. 5 times 4 is 20. 5 times c is 5c. Negative 2 times 4, that's negative 8c. Negative 2 times c, negative 2c squared. Okay, 5 minus 8, that's negative 3. No, I want positive 6. I could try switching the signs, but that's going to give me positive 3. I want positive 6. So instead of 5 and 4, let's see, factors of 2, factors of 20, it can't be 2 to go with the 2c. It can't be 4, it can't be 10. This has got to either be 5 or 1. Let's try it with 1. Let me just write a new one here. So 1 minus 2c and 20 plus c here. So that's 20 times negative 2, negative 40 plus 1. That's negative 39c. And that's not going to work either. All right, so what am I doing wrong here? It could be that it's not factorable, but I'm not willing to give up yet. I know what I'm doing wrong. 20, 6, and 2 have a factor in common. Right? 20 plus 6c minus 2c squared, these are all even. I'm so used to avoiding putting factors in that give you a common factor. I neglected the fact that it did have a common factor of 2. All right, now I'm not getting negative 2c, it's just negative c. And to get 10, maybe that's 5 and 2, maybe it's 10 and 1. Let's see here. So 5 times 2 is 10. 5c minus 2c. 5 minus 2 is 3c. There we go. So I just had to factor out that 2. And then I'm good. 2 times 5 minus c, 2 plus c. Now this is a little unusual because the c was at the end. We could have rewritten this. Let's switch colors here. Put the c squared term first. Negative 2c squared plus 6c plus 20. And then factor out not a 2, but a negative 2. Negative 2 times negative 3 gives us positive 6. Negative 2 times negative 10 gives us positive 20. And then we're saying c squared, that's c times c. Negative 10, that's negative 5 and positive 2. Let's check that. Negative 5c plus 2c. Negative 5 plus 2 is negative 3. All right, we're good there. Right? These two expressions are actually equal to each other. C minus 5 is the opposite of 5 minus c, but since I'm multiplying by the negative, I get the opposite of this one where I multiplied by a positive 2. right? And 2 plus c is the same as c plus 2. That addition is commutative there. All right, here's another one with a GCF we can factor out. 22b squared minus 82b minus 24. They're all even, and this is 2 times 11. 11 doesn't go into these, so I'm just going to factor out a 2. Half of 8 is 4. Half of 24 is 12. All right. All right, 11's a prime number. Great. 12, we've got a bunch of choices here. It's negative, so one's going to be positive, the other negative. Let's just try 4 and 3. 44, take away 3. There we go. Right? Again, first guess. Negative 4 times 11, negative 44b. 3 times b plus 3b. Negative 44 plus 3, negative 41. So we're good. 2 times 11b plus 3, b minus 4. All right, 18x cubed. All right, here we've got x is a common factor. And that's it, right? 3 is not a factor of this one. So I factor out the x. And 3 is not a common factor. So 3's got to be 3 and 1, but that 3 can't be with a multiple of 3 here. So I'm guessing that's going to be 2x with the 3. And then 2 times 9 is 18. Let's see if that works. 3 times 18 is 27, plus 2 more is 29. Yep, that was it. So x times 9x plus 1 times 2x plus 3. Okay, just a few more here. 14 plus 15x minus 9x squared. Another one in reverse order. That's fine. X can be on the right side here. To get 9, I'm guessing it's going to be 3 and 3. It's negative, so one's positive, the other's negative. To get 14, I'm guessing 7 and 2. Right? 7 times 2 is 14. 7 times negative 3x, negative 21x. 3 times 2, that's 6x. 3, negative 3, negative 9x squared. All right. Negative 21 plus 6, opposite sign, so 21 minus 6. It's 20 minus 5, that's 15. Negative. I want 15, but I want 15 positive. So let me switch the order of these. So 7 minus 3x, 2 plus 3x. 7 minus 3x, 2 plus 3x. And you see what I did wrong there? This red parentheses, they're helping me to recognize I forgot to put that in there. They're helping me out there. And we could have factored out a negative 1 to put this in standard form, but that's usually not going to make it easier. It's really unnecessary, but it wouldn't be wrong. All right, here, another one where our variable is a common factor. Oh my goodness, that's a huge number. 112v cubed plus 34v squared minus 6v. All right, that's 34, not 39. Which means all of these are even. This is 2 times 3. 3 doesn't go in here. So the 2v is the most I can factor out. Half of 100 is 50. Half of 12 is 6. So that's 56 v squared. Half of 30 is 15, 16, 17. And half of 6 is 3. All right. 56, that's 8 times 7. That's the first one that comes to mind, so I'm going to start there. 3 is 3 times 1. Negative, so opposite signs here. So I've got it's a v. 56v squared minus 8v plus 21v minus 3. There you go. I'm only writing the outer inner because that's all I have to check really, right? So 21 minus 8, that's 20 minus 7, that's 13v. I want 17v. Well, that was pretty close. Let's see what happens if I switch the 3 and the 1. So 2v, 8v plus 1, 7v minus 3. That gives me negative 24 plus 7. Let's see, 24 minus 7, that's 17, negative 17. I want positive 17. So I'm pretty much there. I just need to switch the signs. And again, no common factors here, no common factors there. 2v was the only common factor. So I've got 2v times 8v minus 1, 7v plus 3. And our last problem here, 49 is a perfect square, 9 is a perfect square. I'm tempted to jump to the conclusion that this is a perfect square trinomial, except my middle term is not even. Right? If I did 7v plus 3 squared, right? 7 squared is 49, 3 squared is 9. 7 times 3 is 21, double 21, you get 42. I only have 41, so that's wrong. So how else can I factor 49? Well, 7v and 7v sounds good. 9, maybe instead of 3 times 3, it's 1 and 9. So there's 49v squared and 9. 7 times 9, that's 63 plus 7, that's 70v. Nowhere close to 41v. All right, well, instead of 7 and 7, these are both prime. My only other choice here is 49 and 1. Now 9 times 49 is a huge number. That's going to be way too high. So maybe it's 1 and 9. So 49v plus 9v. No, that's still more than 41v. I don't even have to get 58. I know it's more than 49, which is more than 41. So maybe it's 49 and 3. But 3 times 49 is going to be bigger than 49. It's bigger than 41. There's no other there are no other options here. 7v and 7v with 3 and 3 didn't work. With 1 and 9 didn't work. 49 and 1 with 3 and 3 didn't work. 49 and 1 with 9 and 1 didn't work. Those are our only options. So we've proved that this trinomial is not factorable. There you go. So take a minute to read that when it shows up on your own. And that's it for this video. I hope running through these quickly was helpful to you. And you can go through, not as quickly, but you can still go through that guess and check process and not be discouraged.